People, stop everything. Brand new images of 3i Atlas just dropped, and they completely reshape the entire board. Yes, completely. You're about to see, or hear, a sequence of evidence that breaks the simplest explanation. It's just another comet. It isn't. It hasn't been. The photos were captured by different observers between November 16 and 17, 2025 from Canada's NEOSat, to amateur records from New Mexico, to recent images from Puerto Rico. They all show the same point. Atlas remains intact and displays jet structures that do not behave like conventional cometary jets. Here's the hook. An intense, forward-facing jet with a reddish hue is present in several images, while, at the same time, traditional jets point backward. How can a natural object produce such selective color and orientation? And how does it maintain structural coherence even though these jets, according to the physics we know, should have torn it apart? The answer, or rather, the questions are far bigger than you think. Let's be practical. The images surfacing this past week show three striking features: a jet facing the observer, forward, with a reddish tint, several receding jets, backward, often symmetrical, and the preservation of the object's core even after perihelion passage. Observers like Satoru Murata, New Mexico, Efraim Morales, Puerto Rico, Rolando Lagusti, and the NEOSat collections agree there is no visible fragmentation, meaning that quick argument, oh, the jets are from fragmentation, loses strength because the object seems whole. There was also a curious behavior in the colors. When brightness, levels, and saturation are adjusted, the forward-facing jet highlights in red and magenta tones, while the traditional tail leans toward greenish and bluish tones. This isn't an aesthetic detail, it's a clue about chemical or physical differences between emissions in opposite directions. How would a single natural body choose different colors depending on jet direction? Does that make sense for known comets? It doesn't. Here's the part that makes specialists swallow hard. When you try to calculate the mass flow needed to power these jets, the numbers become extremely uncomfortable for a simple explanation based on ice sublimation. Imagine this. To sustain jets stretching millions of kilometers in opposite directions, with a typical gas outflow speed comparable to local sound speed, you'd need an enormous mass flow. In simple terms, it would require material on the order of billions of tons over weeks. To sublimate carbon dioxide at that scale during perihelion, the required energy hits the realm of 16 to 18 digits, an amount that the star at the center of our system, at that distance, would not plausibly deliver to a nucleus of the size estimated by high-resolution images. Put another way, for Atlas to expel all that mass solely through solar heating, it would need to absorb energy over an area equivalent to thousands of square kilometers, far larger than the projected area for a nucleus with the diameter estimated by telescopes like Hubble. Replace carbon dioxide with water, and the numbers get even worse. The required area skyrockets. And there's more. The jets appear collimated, highly directional, and maintain orientation over long distances despite the object's measured rotation. That breaks the intuition that simple rotating ice pockets should spew material randomly. Given this scenario, three explanatory paths emerge and deserve serious exploration. One exotic cometary object, still possible, with caveats. The conservative explanation admits that physics and chemistry in distant regions of the universe might produce behaviors unknown to us. Maybe certain ices, porosities, or thermal regimes generate narrow, color-selective jets. But for this hypothesis to hold, it must account for both mass scale and structural integrity, something that currently demands energy counts that are hard to justify. 2. Technological object, bold and scientific. Avi Loeb and others argue for seriously considering the hypothesis that some features resemble technological signatures, directed propulsion, materials similar to industrial alloys, non-cometary mass behavior, and non-gravitational accelerations consistent with engineered jets. This is not a declaration of "it's alien." It's an exploratory hypothesis. If there are signs consistent with technology, we must test them with instruments, samples, and missions exactly as we would if we suspected an artificial human-built artifact. 3. Plasmatic life or plasmatic organism, radical but coherent. A completely different proposal suggests Atlas could be a plasma-based lifeform, a self-organized system capable of interacting with electromagnetic fields, moving, and even altering its appearance. Research on plasma structures in Earth's thermosphere and theoretical studies describe self-illuminated cores, accelerations, and clustering reminiscent of biological behavior without carbon as we know it. This redefines the concept of life and demands reopening astrobiological vocabulary. All hypotheses have conceptual costs. Honest science does not discard any of them out of prejudice. It tests them with rigorous data. If we want to move forward without dogma, here are concrete, immediate steps. High-resolution imaging. Waiting for higher detail images, for example, from spacecraft cameras or high-resolution telescopes, is a priority. Successive images can close or open hypotheses. Targeted spectrometry. Measuring chemical composition precisely. Nickel without iron or anomalous metal proportions is a clue that needs independent confirmation. Dynamic monitoring. Tracking jet orientation over time to correlate with the object's rotation. If jets remain fixed relative to space instead of rotating with the nucleus, the implications are significant. Sampling missions. If technically and financially feasible, sending a probe to collect material could be decisive. In situ sampling would break or validate hypotheses. Interdisciplinary channels. Plasma physics, astrobiology, aerospace engineering, and planetary science must work together quickly. Recap: the 12 anomalies still without explanation. Before moving forward, here are the 12 points that remain outside any ordinary explanation. Memorize them, share them, and demand clear answers. 1. A retrograde trajectory perfectly aligned with the ecliptic plane, something nearly impossible for interstellar objects. 2. Jets directed toward the star at the center of our system, producing an anti-tail not attributable to viewing angle alone. 3. A nucleus with mass far above expectations for interstellar travelers moving at high speed. 4. An arrival timing that allowed close passes by Mars, Venus, and Jupiter, improbable without extreme coincidence. 5. A plume rich in nickel, with levels far above typical comets and solar system bodies. 6. Gas emission, with almost no water, roughly 4% water content, unusual for comet standards. 7. Strongly negative optical polarization, never recorded in known natural objects. 8. Apparent origin near the same sky region as the WOW signal, a coincidence striking even to skeptics. 9. A sudden brightness increase accompanied by a deeper blue hue than the reference star. 10. Jets requiring an absorption area incompatible with the estimated nucleus size, suggesting major energy discrepancy. 11. Non-gravitational acceleration indicating loss of about 13% of its mass without a visible cloud to justify the ejection. 12. Extremely collimated jets maintaining direction across millions of kilometers, ignoring the expected rotation of such bodies. Each anomaly is serious on its own. Together, they form a set of questions that simply does not fit conventional models and demands rigorous, transparent, verifiable investigation. What it means for science and the public. There are two risks if the scientific community reacts poorly. The first is dismissing anomalies and losing the chance to discover something new and transformative. The second is turning a legitimate scientific hypothesis into a spectacle without method. The ideal path lies in the middle: vigorous curiosity, rigorous testing, and clarity in public communication. The public deserves transparency. Scientists often avoid speaking before having a final answer out of fear of being wrong, but science moves through trial and error. Showing the process, doubts, tests, refutations, educates, and brings people closer to real knowledge. Atlas is not just another visitor. If it's an exotic comet, we'll learn something new about the diversity of interstellar objects. If it's an artifact, the cultural and scientific impact will be monumental. If it's a plasmatic life form, we will have to rethink what we call life. In all scenarios, the implications are profound. That's why I insist. Observe with a critical eye, but don't discard hypotheses based on dogma. The investigation is open, and the coming days, the next images and measurements may flip the switch. Our role, as the public and as curious minds, is to demand transparency, support rigorous science, and keep an open mind. What convinces you more in this tangle of images, calculations, and reports? An exotic natural explanation, a technological origin, or something even stranger like plasmatic life? Comment and share. Don't expect a verdict today. Expect science to do what it must. Test, err, correct, learn. I'll keep following everything and bring updates as soon as they appear. Stay tuned.